Our first speaker comes to us from Umea University in Sweden, where he is a postdoctoral fellow. Dr. Thomas Garrison, and my notes don't actually give the title of his talk, but so I'll go to the other notes. Who's going to give us, who is going to present remote ideas from remote locations, technology and Maya settlement archaeology. Please welcome for his first visit here at the Maya Weekend, Dr. Thomas Garrison.
Okay, thank you to LOA for inviting me to speak at this conference today. And I'm going to be talking a lot about remote sensing technology in the Maya lowlands. And I'm also going to be talking about geographical information systems, or GIS, which is the context in which we pretty much are viewing all of our remote sensing data these days. There are many types of remote sensing, as Dr. Scherer alluded to a couple of them. I am going to be talking primarily about spaceborne and airborne remote sensing, but we also use the term remote sensing to describe these geophysical investigations that people do, like ground penetrating radar, but that is not the type of remote sensing that I'll be focusing on. And it's also important to know that remote sensing data is just one data set that we use in archaeology, that we use in a conjunctive approach in order to have a more holistic understanding of the past. So we have the remote sensing data, but we also have paleo-environmental data, which Cameron McNeil will be talking about. We have the epigraphic record, which Simon Martin spoke about last night. And then we also have, good old artifact analysis, like the workshop that'll be going on at 10 o'clock. So in today's talk, I'll give a brief history of the remote sensing applications in the Maya area. And then I'm going to give two case studies from sites I've worked at, both of which were mentioned by Simon last night. First, I'll be talking about multispectral satellite applications at the site of San Bartolo in northeastern Guatemala. And then I'll be talking about radar applications at the site of Zotz, where I am currently one of the directors of the project with Stephen Houston in the central Penn. And then finally, I'll look at anthropological research on political structure and interaction that we can gather from the application of these remote sensing technologies. So to jump right in, the history of remote sensing in my area can be considered to begin with a flight that Alfred Kidder and Colonel Charles Lindbergh made over the Yucatan Peninsula. And there's a quote from Kidder from 1930. He says, "And above all things, we wish to get an idea of what the Maya country really looks like. For in spite of the fact that archaeologists have for many years been pushing their way into that region, they have been so buried in the welter of forest, their outlook has been so stifled by mere weight of vegetation, that it has been impossible to gain a comprehensive understanding of the real nature of this territory, once occupied by America's most brilliant native civilization." So even in the 30s, Mayanists were pretty into how brilliant the Maya were. Modern aerial photography was best applied first by the University of Pennsylvania's Tikal project, and also at Copan, so two sites very important to the University of Pennsylvania. In Tikal, the aerial photographs were not very successful in terms of identifying the extent of settlement. They were able to use the aerial photographs stereoscopically in order to derive better contour maps of the region, but overall they weren't successful in identifying settlements. In Copan, where much of the vegetation had been cleared, there was much more success using the aerial photography in conjunction with ground survey. Remote sensing using radar technology began in the late 70s, and Dick Adams, Pat Culbert, and Walter Brown from NASA flew a radar over northern Belize and identified what they believed to be this extensive system of canals throughout the entire lowland area, and they thought that this would revolutionize how we understood Maya agriculture in particular. Unfortunately, due to an artifact of the processing of the technology, many of these canals were proven to be not real. When they went to look for them on the ground, they did not exist, and this was extensively shown to not exist by Kevin Pope and the late Bruce Dahlman. And unfortunately, because of how unsuccessful this was, it kind of scared Maya archaeologists away from these sorts of technologies for about a decade. But Tom Seaver at the Marshall Space and Flight Center in Alabama brought a new radar technology called the Star 3I in the 1990s, and in collaboration with Patrick Culbert, began identifying these islands in the Bajos, or the large seasonal swamps in the Penn. And when the archaeologists went out to ground truth these islands, they found that there were modest settlements on them, and they seemed to be these, what were called Bajo communities, these groups of people that were living in these areas, probably to extract resources specific to this sort of environment. So, Seaver, having finished that work, was looking for a project to test new satellite technology in the Maya lowlands. Before 1999, the Landsat imagery was the highest resolution satellite imagery that we could really get over the Penn. And this is Central Tikal, obviously, with a resolution of about 30 meters per pixel. But in September 1999, the Icono satellite was launched, and this is the exact same area. And this was sort of a resolution revolution for us. And you can see how this would change the way that we would use these applications in archaeology. So, Seaver contacted Bill Saturno, the investigator who discovered the murals at San Bartolo, and asked if he would like to try to use some of these satellite images in the work that he was doing there, where I was a beginning graduate student. So here we are in the northeast Penn, and this is a line map of the San Bartolo area. San Bartolo is here in the center, and the major site of Xoltun is down here to the south, and I'll mostly be talking about the area where I did my dissertation, which is those two sites in the area in between them, but I'll look at some of the imagery from the rest of the area as well. So Saturno, Seaver, and I were looking at the satellite imagery, and we noticed these areas where it was sort of bluish yellow. I don't know if you guys can see that. Can we make the lights a little darker by any chance? Yeah, so this was this bluish yellow signature, and when we put the ruins of San Bartolo on top of it, we found that the architecture coincided with the areas where this vegetation was discolored. And what we were seeing was, we were seeing stressed vegetation. For some reason in this area, wherever ruins were, the vegetation that was growing on top of those ruins was not receiving enough nutrients to continue their chlorophyll production correctly, and it was creating this discoloration. So here's San Bartolo again, and we looked around the region and we began doing regional reconnaissance, and we identified sites like Chaqueque, Las Minas, La Prueba, Casas Pintadas, and then two other sites that we didn't get a chance to visit, but based on this pattern, we're pretty sure there are other settlements in that area. So for my dissertation, I was looking at areas where that settlement signature was not as strong, but we knew that there were Maya ruins on the ground, and I was trying to basically find out to what precision we'd be able to use this technology to help us in settlement archaeology. And the conclusion, unfortunately, was basically that the Iconos imagery was very good for identifying the largest sites and some of the minor centers in the area, but anything at the sort of residential or household level was not being reliably detected in the satellite imagery. This was the survey that I did a percentage of these blocks, and these black lines are the logging roads that were going through the area. There was active logging, and oftentimes we were maybe one day ahead of the loggers before they would come in and plow the areas. And then, yeah, these yellow trails are all my GPS wanderings over a number of seasons. So, since it was difficult to detect any sites below the sort of minor center level, I then looked at Google Earth and I said, hey, well, we can sort of see this here anyway, so why do we spend all this money on the imagery? You can see, I mean, it's sort of showing up anyway. And other projects had purchased this imagery as well and were not having as much success with it, and they asked me to look at their imagery. And so Stephen House and Zotz showed me his Iconos imagery, and when we processed it, it looked like maybe there was some faint signature in this area between the sites of Zotz and El Palmar, but it was nothing very strong, and when we ground truth, there was not anything to indicate that there was any type of different settlement in that region. Takeshi and Amada, working at the site of Ceibal, also in Guatemala, one of the best studied and best mapped sites in the Maya lowlands. This vegetation is all bright, bright red, no discoloration whatsoever, which means that it's extremely healthy. So again, we're not seeing this pattern at all of stressed vegetation. And then Charles Golden, working along the Usumacinta River, he had these areas that did look very stressed, but most of them had no settlement on them, and the one that did, the site of Bayal, the site was about the size of this room, and it should have been much, much larger, so we were having false positives as well. So I was looking for other applications for this satellite imagery, and during my survey around San Bartolo, I had also mapped environmental zones, and I had sort of made a mental note that there were different types of architecture and density in different environmental zones. And so what I needed was I needed the computer to be able to classify the environment for me over a much larger area, and I figured that would allow me to extrapolate my survey over the entire area covered by our remote sensing data. So I tried something with this cumbersome name, the Iterative Self-Organizing Data Analysis Technique, which is a classification technique for satellite imagery in which an algorithm is applied to the image, and it takes each pixel and assigns it to one of a number of classes that you've assigned. And ideally, this brings out patterns in the imagery. This was my first go at it, and the only thing that was successfully classified were the shadows of the clouds. So this was not particularly helpful. So the next season, we got a QuickBird image, which is another kind of satellite image. It uses the exact same type of sensor as the Iconos imagery, but it flies at a lower orbit, so it gives it a higher resolution. And the major difference was that compared to 2003, when this image was acquired, in 2004 we had a severe drought in this area. So when the image was acquired, there was already major differences that could be seen in the different microenvironments in the area just because of the stress on the landscape. So when I classified that one, we got a much better result. Unfortunately, we could only get uplands and lowlands as designations. There are much more subtle differences in the landscape there, but the quality of the algorithm could only bring this out, but it was still a big step in terms of being able to quantify the amount of terrain the settlement was occupying in the landscape. And this is just to show you the original scene in comparison with the classification. All these white squares are the blocks that I actually tromped around to and surveyed. So, in comparison to the vegetation I recorded during survey in the same blocks, these were the percentages of uplands and lowlands. So it's a difference of about 4.5%, which in remote sensing terms is basically nothing. And what this allowed me to do was, using these complex equations that Mayanists like to apply to the number of structures that they have in an area, I was able to extrapolate the survey data that I had over the entire region. I came up with this structure density and this ridiculous figure of there were 7,710 people living in the area. That's not meant to be taken seriously. It's more that if you look at this data in contrast to all the other sites where this same equation has been applied, we get sort of a relative idea of the density of settlement and population size, rather than maybe believing these absolute numbers. But this density of 97 structures per square kilometer was comparable with peripheral settlement around Tikal and Copan and other large late classic sites. So this would have been for Schultun. And this was at a fraction of the cost and time in terms of survey effort. So that was what I did my dissertation on, and then after collaborating with Steve Houston with that Iconos imagery, he invited me to direct the Zotz project with him just west of Tikal. And the first thing I did was I spent a lot of money on another new type of satellite imagery, this one called GOI-1, again hoping maybe we could get this San Bartolo satellite signature to work, but we couldn't. But I did find some uses for the GOI imagery. We were able to see areas of secondary growth after forest fires, which let us know that it was going to be a pretty miserable day doing survey. And then we were also able to see where there were illegal settlements coming into the biotope, which allowed us to keep clear of those, because they don't really like people telling them they shouldn't be there. We were also able to use the GOI-1 for our paleoenvironmental research, finding areas for my colleagues Tim and Cheryl Beach to take water samples from, and also to look at drainage features in our bajos. But more successful at Zotz was the use of AirSAR data. This is airborne synthetic aperture radar. Bob Scherer was involved in the grant that arranged for this plane to fly over the Penn in 2004. And they collected data over all the areas that you see here. Zotz is located about here. This is a long swath along the Usumacinta. And there were some problems. When they originally processed the data after collecting it, it had these ripples in it. And they thought that it was going to be kind of a wash, that it just wasn't going to work. But Bruce Chapman at the Jet Propulsion Lab came up with a new algorithm for calibrating the data, and he got it to look the way it was supposed to. And due to months of my harassing him, he gave me a large swath of it over the area that we were working at. And in 2009, we brought it to the field to try to ground truth some of the things that we were seeing in the data. So the first thing that we did was we took our site map, and we were able to see that the major pyramids were showing up in the data. And this allowed us to rectify our maps to our remote sensing data, making sure that everything was in the exact right place and at the exact right orientation. And then also noticed some strange features in areas between our major sites. So we had these rectilinear features in the landscape showing up in the data, and when I went to ground truth this, found the site of La Avispa, which means the wasp, because I was stung in the face by a wasp when I found it. After identifying that, we looked around in some other areas. This had a sort of strange squared off shape to it, and up on the top of that hill there was a looted pyramid with a vaulted tomb on the inside that unfortunately had been completely cleared out. And we are also able to use the data to find the elusive residential settlement areas around Zotz, which we began mapping during the 2010 season, and will continue over here in about 2 weeks. But as with the satellite imagery of San Bartolo, we were still only finding really the largest areas of settlement in this region. We were finding the sort of first tier and second tier sites, and again, a vegetation block survey was required to help fill in some of the areas that we were missing. So, how does this data apply to some of the bigger anthropological questions that we want to investigate as archaeologists? And my own research is focused on political structure. So, in colonial Yucatan, there was this term, Kuch Cabal, for provinces, and it's glossed under many different terms for, it says provinces, territories, hamlets, place, but the root of it is this word Kab, meaning earth, and we do have this glyph compound from Stela 31 at Tikal, Chan Kab Chen, or Sky Earth Cave, And as Simon mentioned last night, this is often broken down into these sort of metaphorical couplets. Chan Chen, or sky cave, is often used in a cosmological sense where it follows a place name. And I believe that the toponym or place name that precedes this is substituting for the Cobb or earth portion of this sort of tripartite combination. And then we have this other Uka Uchen, which refers to a more physical territory, a territorial capital and its surrounding sort of hinterlands. And I was interested in seeing if we could determine boundaries for where these settlements were. And I looked to the ethnographic and ethnohistoric record, and the Chorti Maya, as documented by Charles Wisdom, looked at boundaries as being marked by a slight rise in trails, large boulders, or the crossing of trails by a stream. And then the Zapotec Lienzo de Guevea and the Mixtec Lienzo de Jicayan show boundaries often being represented by major physiographic features in the landscape, whether they mountains or rivers or things of that nature. And so I identified a number of capitals, or what I believe to be territorial capitals in this area called the Three Rivers region in northeastern Pretend and northwestern Guatemala. And instead of doing what are called decent polygons, where you say, okay, well, these two sites were capitals, we'll draw a straight line between the midway point between the two centers, I instead identified the major geophysical feature between the two sites and came up with these sort of hypothesized territorial boundaries. Now the problem is that they are just hypothetical, and I needed a way to try to test them, which is what I'm working on right now. Another factor that came into play were view sheds. So using the remote sensing data, we can say that this is all of the area visible from the pyramids at Tikal, and this is all of the area visible from the pyramids at Zotz. And when we put them together, we have these sort of three viewshed interfaces. And one of the things that's interesting is that at this middle one is right where they built the wall separating Tikal from Zotz. And in this case, we have a cultural boundary where there is no doubt that this was the boundary. So it's a good way to look at data on either side of the boundary in order to identify how we might be able to see differences in the archaeological record between two sites that held control over different territories. Continuing with the use of remote sensing data between Zotz and Tikal, grad student at Brown University, James Doyle, and I began looking at least cost corridors and shifting viewsheds in the area. So by running a number of different algorithms through the area, we identified wet season and dry season possible corridors rather than single straight lines, which would be very difficult to test. And then we noticed that in the pre-classic, Zotz seemed to have much greater visibility over the Buena Vista Valley. This is the view from the Mundo Perdido pyramid at Tikal, which would have been the largest structure at the time. But then in the late classic, when Tikal sort of explodes in size, this is the viewshed that Tikal is covering compared to the major structures at Zotz. Some of the stuff that I'm showing right now with viewsheds and least cost is important to remember, because this afternoon you're going to see the Chase's data, which is going to blow all this stuff away. This incredible LiDAR technology that they have where you're able to see, very, very small structures. But that data is very, very large in size and takes a lot of processing power. And so to do this sort of regional scale viewshed and least cost stuff until computers eventually catch up in terms of processing speed, this sort of lower resolution data is actually maybe a little bit better for those types of studies.
Could you explain what a viewshed is, please?
Sure. A viewshed is basically you put a point where you, the viewer, would be standing, and by running a computer program over all of this data back and forth, it determines which spots would have been visible in the landscape from the point that you say that that person is standing. So in this case, this purple dot is the viewer standing on the tallest pyramid at Tikal and the view of the landscape around.
With or without trees?
That is a good question. We are actually working on the assumption based on our paleo-environmental data that most of this area would have been clear of vegetation at this time, particularly in the late Classic.
Which is convenient because that's what your data is.
I'm sorry?
Which is convenient because that's what your data looks like.
Yes, it is very convenient. There are ways to modify viewshed analysis to account for vegetation, but since our paleo-environmental scientists are saying that there wasn't significant vegetation in the area, we have not run those. So, for looking at boundary issues, on either side of the Tikal wall, we're currently looking at differences from the settlement survey. We're looking at epigraphic and iconographic data on either side of the boundary. We know that Zotz and Tikal had a contested relationship for much of their history. We're looking at different architectural styles. We're looking at differences in ceramics, not only in terms of type variety, but also in terms of petrography, which is the study of ceramic composition, which basically lets us know if different materials are being used to create ceramics or different sorts of temper imported from different areas, which might indicate different exchange networks for two different polities. The same thing for lithic analysis, particularly obsidian. We do sourcing of obsidian, which lets us know if two settlements are bringing in their obsidian from different highland sources, which again would suggest they're in different exchange networks. And then I just had to show this royal tomb we discovered at Zotz last year because we like to promote that, but we look at different burial patterns between sites as well. All of this data is still in process. The work at Zotz is ongoing, but we're hoping to get some meaningful results so that we can take the differences between the archaeology of Tikal and Zotz, see what we can learn about data sets on either sides of a known boundary, and then go back to areas where we have hypothesized boundaries and see if we can make clearer statements about where these territories were separated from one another. So, just to wrap it up, history of remote sensing in the Maya area is one of mixed results. Almost every technical paper in remote sensing in Maya archaeology ends with, this technology has great potential, and then they move on to the next one. And the proper technology needs to be selected for the region being studied. There's no universally applicable high-resolution technology, and I put a big yet here. Again, you will see the chases off this afternoon. And moving forward, these technologies need to be applied within well-structured surveys where they can enrich the settlement data. So even with the really, really high-res data that's coming out now, we still need to do, or I should say we still get to do ground survey. These technologies are never going to replace archaeologists going to the field and doing the research that we love to do. And then the study of political structure and interaction is just one area of anthropological research that could benefit from remote sensing. And it's important that we integrate the technologies that we're using into our anthropological study of the Maya so that we're not just doing sort of high-tech wizardry, but we're really focusing on answering anthropological